So, modelling with series. There's quite a few real life situations where this kind of work is used, and we're going to look at one here. So, example 22, Bruce starts a new company. In year one, his profits will be £20,000. Yeah, in year one. So that's already setting up for us a value of A, isn't it? Yeah. A starting value. He predicts his profits to increase by £5,000 each year. So it's increasing by a fixed amount. So I'm now thinking this is an arithmetic kind of context because it's increasing by the same amount each year. So his profits in year two are modelled to be, so year two, £25,000, so that's gone up by 5,000. In year three, 30,000, so it's gone up by 30,000. Another 5,000 in the third year, and so on. He predicts this will continue and he reaches an annual profit of £100,000. He then models his annual profits to remain the same at £100,000, calculates profits for Bruce's business in the first 20 years. So, the key thing here is to pick up that does profits reach £100,000 before 20 years, or before the 20th year. So, just start these, are usually best started by lifting out some information. So when n equals 1, profit is equal to £20,000. 20,000. When n equals 2, profit equals £25,000. When n equals 3, profit equals £30,000. So we can see we've got an arithmetic sequence. Arithmetic. Therefore, we're going to have A equal to 20,000 and D equal to 5,000. And we want to know when the sum equals £100,000, when the profit equals £100,000. So profit in 1 year is equal to A plus n minus 1 lots of D. Yeah, where profit is like our UN in our learnt formula. It's the amount that we've earned that particular year. So we can now substitute in. We want the profit to be £100,000, starting at £20,000, and it's n minus 1 lots of the difference, which is £5,000. So you've got 80,000 divided by equals n minus 1 times 5,000, divide by the 5,000, so 80 divided by 5, that's 16 equals n minus 1, so n equals 17 years. Okay, now we want the profit in the first 20 years, so we want to find the sum, need sum of first 17 years plus 3 years at £100,000 a year. So we need the equation for the sum of the first n terms of an arithmetic sequence, which hopefully you have learnt now. Sn equals n over 2 times 2a plus n minus 1 lots of D. And we've said we need the sum of the first 17 years. So S17 is equal to 17 over 2 times 2 lots of the first term, which is £20,000. Whoops. 20,000, good. Got that right now. Plus N, which is 17 minus 1 times the difference, which was £5,000. Okay, so that means we've got 17, cancelling the 2's, times 20,000, plus 17 minus 1 is 16, divided by 2 is 8, so it's 8 times 17 times 5,000. You can tap that in the calculator, and it comes out to be £1,020,000 in the first 17 years, but we want the total profit in 20 years. Total profit in 20 years. So we've got plus 3 lots, so we've got 1020,000, the first 17 years, plus 3 lots, and his profit then stays fixed at £100,000. So this was the first 17 years. First 17 years, plus last 3 years. So that adds an extra £300,000. So we get 1320000 as our final answer. Part B. State one reason why this may not be a suitable model. Well, profit is unlikely to increase by the same amount each year. Yeah. There's going to be some inflation and that kind of thing, and some years you're going to have a bad year, other years you're going to have a good year. It's very, very unlikely. Okay, part C. Bruce's financial advisor says the yearly profits are likely to increase by 5% per annum. Using this model, calculate the profits for Bruce's business in the first 20 years. So again, we've got to recognise the context here. So finance says that yearly profits increase by 5% per annum. Okay, so if it's going to increase by 5% per annum, what kind of sequence is that going to be? Well, it's going to be different amounts each year, and a percentage increase is a multiplying factor. Yeah, it's multiplying by 105 over 100. That's how we increase something by 5%. And because it's a multiplying factor, that suggests to us that it's going to be a geometric sequence, and adding them up to make it into a series. So the sum of the first n terms of a geometric series, hopefully we've learnt, is A, and we're going to use Rn minus 1 over R minus 1, since the modulus of R is greater than 1. Well, why is the modulus of R greater than 1? Well, if we come back, I identified up here that our multiplying factor for percentage increase was 105 over 100. So R is going to be equal to 105 over 100. That's our 5% increase. year on year. Okay, so S20 then is equal to A, which is still going to be the starting value. R is going to be 1.05 to the power 20, take away 1, divided by 1.05 minus 1. The 1.05 is 105 over 100, which is our R value. Okay, so that really is a calculator kind of activity. Tap it in, and we're going to get 6, 1, 3, 1, 9.08. So Bruce's profit over 20 years is profit in first 20 years. Right. Not that I'm going to do it, but it's quite an interesting question to think, will the first model always produce more profit than the second? Yeah, the arithmetic or the geometric, or will over time the geometric produce a better profit? And well, I know that it will be the geometric, because the geometric graphs go like this. They get steeper and steeper and steeper, and the graph for the arithmetic is adding more each year, but then it becomes a straight line. So it increases quite steeply to start with, but then it will go as a straight line across, because you're the total profit, yeah, goes like that. So eventually the geometric is going to produce more income or more profit.